Okay, let's continue with 6.4. So adding or subtracting rational expressions, find the least common denominator, which is what we've been practicing in the last video. Multiply the fractions by whatever they're missing from the common denominator. Remember, we can only multiply by 1, so anything we multiply the denominator by, we also have to multiply the numerator by. From here, we can combine our like terms or distribute as needed. And then we can add or subtract across the numerator, and then reduce if possible. So let's start with an easy one. 2 over x plus 2 plus x over x plus 2. Here my common denominator is x plus 2. They have the same denominator already. I don't need 2 x plus 2s, just 1, because the largest power of x plus 2 I see in any one denominator is to the first power. So I can straight add without getting a common denominator here because there's nothing missing. So when I add it across the numerator, this is 2 plus x over x plus 2. Now remember, 2 plus x is the same as x plus 2. Anything divided by itself is 1. So let's step it up a little bit. 1 over 2 minus 1 over y. My common denominator here, I'm going to need a 2, and I'm going to need a y. So what is the 1/2 missing? It's missing y, so I multiply my denominator by y. Anything that happens to my denominator also must happen to the numerator. The 1 over y is missing the 2, so anything that I multiply into the denominator also gets multiplied into the numerator. So this is y over 2y minus 2 over 2y. I'm going to put them in order. Now that they have the same denominator, I can just subtract across the top, the numerator, y minus 2 over 2y. Now, what does this do for us? Well, now it's all in one fraction. Can I do anything with this is the question. I see 2 y's and 2 2's, but I can't cancel those out. Remember, these are connected factors. Y minus 2 is connected. 2 and the y are connected by multiplication, but there's no 2 by itself multiplied up top. There's no y multiplied by itself in the numerator, so I can't cancel anything out. The thing that people most frequently make an error when doing these questions on is canceling things out that they can't actually cancel out. Let's do some more. Let's look at number 3. Z squared minus 2z over z plus 4 minus 24 over z plus 4. We already have our common denominator of z plus 4 in both fractions. When I subtract across the numerator, I get z squared minus 2z minus 24 over z plus 4. Now when you have a quadratic here, if you put this into the answer in your homework, they might tell you that you have the right answer, but it's not in its most reduced form. And that's because we can actually factor this. What are two numbers that multiply to negative 24, that add to negative 2? It's negative 6 and positive 4. This is z minus 6 times z plus 4 over z plus 4, which means we have a common factor we can reduce. Z plus 4 over z plus 4 reduced to 1. So the only thing that should be left is z minus 6. I'm going to leave 4 for you guys to do. Let's look at 5 and then possibly 6 when we're done. J over j plus 4 plus 6 minus j over j minus 16 over j squared plus 4j. So first I'm going to factor my denominator that's not factored. These have a common factor of j that I can factor out, so I also have a j plus 4. So my common denominator here, I need at least a j to cover these two, and a j plus 4 to cover those. And that covers every factor in my denominator. So my first fraction is missing just the j. So j over j plus 4 times j for j. Second fraction is missing the j plus 4. And again, anything you do to the numerator, you also have to do to the denominator. The last one's not missing anything, so I leave it alone. So here I get j squared over j times j plus 4. This one I'm going to have to multiply. It looks like I've got 6j minus j squared plus 24 minus 4j all over j times j plus 4, and I'll clean that up in a second. Minus 16 over j times j plus 4. So we've got j squared, j times j plus 4, plus, reordering it, negative j squared plus 2j plus 24 over j times j plus 4, minus 16 over j times j plus 4. Okay, let's see what we have here. I'm adding across the numerator and then subtracting. J squared plus negative j squared cancel. So then we have 2j plus 24 minus 16. 24 minus 16 is 8. It's 2j plus 8 over j times j plus 4. Now I can even go a step further than that. These share a 2 that I can factor out. This is 2 times j plus 4 over j times j plus 4. And here, the j plus 4's will cancel or reduce to 1, and I'm left finally with 2 over j. So it simplified a lot after we performed our operations. So just keep that in mind. It is possible for that to happen. Okay, and one last one, number 6. Again, factor your denominator. This is w plus 3 and w minus 3. The second one is w minus 7 and w plus 3. So what do I need to do? My common denominator, I need a w plus 3, a w minus 3, and a w minus 7. All three of those multiplied together. My first fraction is missing the w minus 7, so we have 5 over w plus 3, w minus 3, missing the w minus 7, so multiply both the numerator and denominator by that. My second fraction is missing the w minus 3. So we multiply by w minus 3 in the numerator and the denominator. So what do we end up with? We've got 5w minus 35 in the numerator over I'm going to write my CD for common denominators because they're all multiplied there. Just make sure we have enough room to see what's happening. My second fraction, I'm going to multiply out my FOIL, or distributive property here, w squared. Looks like minus 3w plus 6w, so plus 3w minus 18 over my common denominator. I'll rewrite it when I combine these here in a second. Add across the numerator, w squared, looks like plus 8w minus 53 over the w plus 3, w minus 3, w minus 7. I don't think 53 factors. In fact, I'm pretty sure it doesn't. I think it's prime, which means we can't factor that and potentially cancel out factors. So what we have to do is multiply out our denominator. We know that these two together is w squared minus 9 multiplied by w minus 7. That'll be w cubed. So w squared plus 8w minus 53 over w cubed minus 7w squared minus 9w plus 63. And that is my combined fraction, and that is all for 6.4.